So, in theory of probability, there are two important concepts. One is Bayes theorem, and another is your the binomial probability. Okay, so we'll solve two numericals on that. Earlier, I have discussed about the theory behind Bayes theorem and the binomial probability. So, in theory of probability, Bayes theorem is very important, and the binomial probability. Okay, so if we have earlier we have discussed about the theory behind it and the derivation. So based on those formulas, we will try to solve two numerical, one on Bayes theorem and one on binomial. Okay, probability. Okay. So let us start with the Bayes theorem first. Okay. So Bayes theorem. Okay. Your Bayes theorem, as we had discussed earlier, it is like probability of any event, ith event, given A is equal to probability of E, and then probability of A given E. Okay. Okay. So then sum of I is equal to 1 to n, sum of probability of E I, okay, probability of A given. So this is your this is the generic expression for Bayes theorem. Okay. So now let us try to do one numerical based on it. Okay. So the question is a bag 1. So you have a bag 1. Okay. You have this bag 1. Okay. Okay. And then you have this bag 2. You have this bag 2. Okay, so the bag 1 contains 3 red and 4 black balls. So it has 3 red and 4 black balls. Okay. And the bag 2 contains 5 red and 6 black balls. 5 red and 6 black balls. Okay. So one ball is drawn at random from one of the bags. Okay. And it is found to be red. Okay. So one ball drawn from one of the bag is found to be red. Okay. So this has happened. So find the probability that it was drawn from bag 2. Okay. What is the, so this is bag 1, this is bag 2. So what is the probability that this red ball is drawn from bag 2? So that's the question. Okay. So first here E1 is an event of choosing bag 1. Okay. So you have two events. Either you can choose from bag 1 or you can choose from bag 2. So E1 is event of
Ball from bag 1.
Event of choosing ball from bag 1. Okay. Okay, then E2 is event of choosing ball from bag 2. Okay. So these are E1 and E2. Okay. And what are the probability of E1 and E2? So
1 by
it
2,
is
1
nothing
by
but there are two bags. So
by
sample
2,
space
1.
is 2. So P1 is equal to half. PE1 is equal to half. PE2 is equal to half. Okay. So and then probability of AE1. Okay. So these terms we have to now find out. So the probability of AE1 is probability of drawing a red ball from bag 1. Okay.
3 by 7.
So probability of AE1 is equal to
3
probability of
red ball from bag 1.
red ball from bag 1. That means it's a conditional probability. So A is event of drawing a red ball. Okay. So A is drawing red ball. Clear? So you know now probability of probability of red ball from bag 1. So what is that probability?
3 by 7.
3 by 7, because there are 3 reds and there are total 7 balls. So it is 3 by 7. Okay. Similarly, probability of AE2, that means red ball from bag 2 is 5 by 11, right? 5 by 11. So you know now AE1, probability of AE1, AE2, PE, everything you know.
You have to find E2A. Probability of E2A.
Yeah, so now the probability of drawing a ball from bag 2, probability of drawing a ball from being given that it is red is PE2A. Okay, so this you know. So now it is getting reversed. So the question is now probability of drawing a ball from bag 2. Okay, so bag 2, you are drawing a ball from bag 2. So probability of E. Okay, bag 2 means it is E2, right?
Yeah.
Okay, so
E2A.
E2
A.
A is red. So probability of drawing a ball from bag 2 give you under the condition that it is red. Given that it is red. So you can see that it is getting reversed. Okay, so this, so probability of drawing a ball from bag 2 given that it is red. Okay, find the probability that it was drawn from bag 2. So first is it is bag 2. Okay, and then given that it is red. Okay. So this, so if you use that formula from that formula, so you can now say that it is equal to P
half into 5 by 11.
So it will become
PE1 into PAE. PE2 into PAE.
PE2
into PAE2.
PAE2. So you can see it is getting reversed. Okay.
Yeah.
AE2. Okay.
Yeah.
Sorry. PAE2. Okay. So PE2. Okay. So PE2A is equal to PE2 given A is equal to PE2 into PAE2. Okay.
By the same thing plus PE1.
So then the whole thing, that summation will come. So the PE and say.
Don't need to write. You can do PE, the same thing in numerator.
So you can do PE1. So you can just write it like this: PE1 into PAE1
plus PE2
plus PE2
into PAE2.
into PAE2. So this is what you want, right?
Yeah.
So now you know everything, okay? You know PE2, you know PAE2, PAE2 you know, okay?
1 by 2 into 5 by 11 by the same thing plus 1 by 2 into 3 by 7.
Okay, so what it will be? Can you tell me?
1 by 2 into 5 by 11.
Okay. So
That diagram you can draw.
okay, so I can write it as PE2 is how much? Half, right?
Half into 5 by 11.
AE2 is how much? 5 by 11, right? Okay.
By
Then
half into 3 by
PE1
7.
is half, okay?
Into 3 by 7.
PAE1, have we write it anywhere?
Yeah, there.
Where?
Up. Right hand corner.
Okay. Half
3 by
into 3 by 7 plus
half into 5 by 11.
half AE2 we have written? Okay.
5
5 by
5
So-
by 5 by 22 by 3 by 21.
5 by 22. Okay. So the final answer is 35 by 68. Okay. So this is the final answer. That probability that it was that the ball is drawn from bag to give him that it is red. Okay. The first is the condition is that it is red and it is drawn from bag to. Okay. So now one numerical on Bayes theorem we have done. Okay. 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 So you have taken the picture, no?
Yeah.
Okay. This is about Bayes theorem. Okay. Now we will try to do one numerical one. Bernoulli's trial and binomial distribution. Okay. So it is Bernoulli's trial and binomial distribution. Okay. So okay. So what is Bernoulli trial and all? I have already explained it, the theory behind it. Okay. So let us try to solve one numerical. Okay, and this Bernoulli trial and binomial distribution. So if a fair coin is tossed 10 times, find the probability of exactly 6 head. Okay. So if a fair coin is tossed 10 times, find the probability of exactly 6 head. Exactly you whatever number of times whatever you are tossing, it is n is equal to 10, right? And mm, yeah, having exactly 6 head, okay. So and what is the probability here? Like it is like either you can get head or you can get tail. So the p value is equal to half, right? So the p value is equal to half, okay. Then what is the probability of getting uh, 10 heads, okay. So it is something like this. So the probability of 6 heads, okay, 6 heads exactly is equal to it is NCR, NCR, okay. So R is equal to 6 head, okay, R is equal to 6. So NCR divided by probability to the power 10 times, right? Half.
P to the power.
So
P and Q. You have to consider Q also.
okay. P, Q. Okay.
Q is also half. P is 1. Q is 1 minus P.
Okay. So what we'll write the generalized equation.
NCX P to the power n and Q to the power n minus.
Okay, so the probability is nothing but the probability of the probability is equal to NCX. Okay, so the you know the binomial distribution. Okay, so the what does the binomial distribution says? So P plus Q to the power n is equal to NC0 P to the power n, right?
Yeah.
NC1 and Q to the power 0, okay. NC1 P to the power n minus 1 Q. So NC2 P to the power n minus 2 Q to the power 2. Like this is goes on, and then you end up with NCN. So it will become Q to the power n. So this is your binomial. So that's why the binomial terms comes into picture here. So the probability of this is probability of 6 head is like NCX. Your let us say this
10
is
C6.
So let us say you can say it as NCR, okay. Then P to the power n minus R, right,
Q to the power
into Q to the power R. So the total power is equal to n, okay. So here that is the probability of getting 6 heads. So here your n is equal to 10, R is equal to 6, okay.
P is equal to
P
half,
is equal
Q is
to
equal
half,
to half,
and Q is equal to half. Okay, so by replacing, so the probability of 6 head, okay, we can write it as 6H, right? So it will be 10 C 6 half to the power 4 and half to the power 6. Okay, so this is the answer. So you will get this value to be 105 divided by 512. Okay. So this is the probability. Okay. Then there is some other questions can be probability of at least 6 heads. Okay. So probability of at least 6 head, that is nothing but probability 6H, okay. Then probability of 7H
up till 10.
Probability of 8 heads plus probability of 9 heads and probability of 10 heads. So that's for at least. That is the meaning of at least. Okay. At most means it will start from 1 head till 6
till
head.
6.
Okay, so now you understand the concept. Using this, there can be many numericals.
Yeah.
Okay, so now you understand the Bayes theorem and Bernoulli's trials and binomial distribution.
Yeah.
Okay, thanks.